Welcome, Pure Maths 1 students, to week 7 of our maintenance. This week we're looking at quadratics, functions, coordinate geometry and differentiation. Topics we have hopefully covered enough detail for you to be able to do these questions. Remember, as I mentioned a number of times before, to ensure that you succeed in this course, you're going to need to put in time outside of the teaching hours. So that's why I've put together these videos and the maintenance for you to keep the knowledge that you've done fresh in your minds. And probably in addition to maintenance, you're going to need to be going over stuff in your textbook and reviewing what you've done as well. Okay, I want some high A's, okay? Alright, let's look at the first one here. We've got to express this quadratic in the complete the square format. So what I'm going to do is I'm going to take this bit here and complete the square for that. So I halve the coefficient 6 square, x plus 3 squared, and then I take away the 9 that would result if I expanded that. So if I expanded this, I'd get x squared plus 6x plus 9. Now that's the bit I want, isn't it? Not this. So that's why I have this take away 9 here. Okay, so that's what I'm doing. Okay, now I want that in the form of, yes, and I also need this here, so I need the plus 2. Alright, so another way of writing it is this, and then we can simplify it, so it's x plus 3 all squared minus 7, and we are done. You might be concerned because it says plus b here, but that's okay. Another way of writing this would be plus minus 7, and b is minus 7, right? Okay. Moving on, so hence or otherwise find the set of values for which this is greater than 9. Okay, for which this is greater than 9. What we're going to do here is we're going to write x plus 3 all squared, take away 7 is greater than 9. Now what I'm going to do is I'm going to find out where it equals 9, okay? So let's just consider this for a moment. X plus 3 squared minus 7, where does it equal 9? And then what I can do is I can bring the 7 across like this to the other side by adding it, so I get 16. Then I can take the square root of both sides, so we get plus or minus the square root of 16. And so we get x is equal to minus 3 plus or minus the square root of 16. Now what I've done here is I've found the two places where we have a root. So we've got a root at minus 3 plus 4. So that's obviously 1. Maybe I'll just change that to a 4. We don't need that anymore, do we? Right, we can change it to 4. This is the one. Right, 4. Or minus 3 minus 4, which is minus 7. So we get something like this. Okay, minus 7, that's positive 1. And we want where it's greater than 0, so what I've done is I took that across to the other side, didn't I, to make it, well, let me just explain. I'm rushing ahead, trying to get this video done. Okay, I could go x plus 3 all squared, and then I bring the 9 across, so I make it negative 16 is greater than 0. Okay, so what I'm plotting here is this. Okay, now where is it greater than 0? Well, here and here. So my final answer will be x is less than minus 7 or x is greater than 1. And we're done with the quadratics questions. Okay, moving right along, now we're on to functions. So we've got this function defined as x squared, and we've got to sketch it. Okay, let's see if I've got an axis. Oh yes, perfect, I can do this. Here's our axis, and we've got to sketch x squared. So this is fx, okay? So let's say this is what we've got. Okay, not particularly brilliant, but that's that. Now, what I'm going to do, just to help us understand this, we're going to go x, and then we're going to go fx. So let's say we have minus 1, let's go minus 2, minus 1, 0, 1, 2. And so we get 4 when we square minus 2, 1 when we square minus 1, 0, 1, 4. Okay, so remember fx is x squared, right? That's what we're drawing here. Okay, now that's that. Excuse the mess. Okay, now let's do another one. Let's do f2x. So what we're going to put in for, so that means it's like 2 times x squared, right? That's f2x. Okay, f2x. So what will happen here is we're going to take this x value here, the 2, and go 2 times negative 2, which is negative 4. Negative 4 squared is 16, right? 2 times negative 1, negative 2. Negative 2 squared is 4, and then that will be 0 again, and then the same out this way. So you see this is quite steep, so f2x is going to be a lot steeper. Ooh, that's horrific. Sorry guys, shaky hand. Okay, that'll have to do, right? And then now we're going to do the last one, 2fx. Now what's going to happen here? Well, that's like 2 times x squared. Okay, so we're going to now draw 2fx. So we get our x squared, this here, which is 4, and we times it by 2, which is 8. We get our x squared here, which is minus 1. We square it. So minus 1 squared is 1. We times it by 2. And so on and so forth. So this one is steeper than the original, but not as steep as the red one. Okay, and I'd probably want to label those as well, but I'm not going to do that in this video because that will take extra time, wasting time. Okay, now number 2, we are trying to express the equation here, which is x squared minus 10x for x is a member of the set of real numbers and x is greater than or equal to 5. We express it in the form of x minus, so we're doing a complete the square. So I take the x, I halve the coefficient of the x term, I square, and then I subtract 25, which is the square of this, and that will be the same. And if you've forgotten, remember x squared, if I expand this here, what do I get? X squared minus 10x plus 25. Now I want that, but I don't want this, so that's why I've got the negative 25 there. Okay, I hope that makes sense. And now it says find an expression for the inverse and state its domain. Now, when you're doing an inverse of a quadratic, use the completed square version. So it's helpful that we got told to do that, because now we can use that. So we're going to go y is equal to x minus 5 all squared minus 25. We swap our x and y values over because that's what an inverse does. It swaps the input and the output. Oh, what's going on here? Come back. Okay. And now I'm going to bring, I've got x plus 25 here is equal to y minus 5 all squared. Now let's just go over here because we're running out of room. I'm going to take the plus or minus the square root of x plus 25 is equal to y minus 5, and then last line, well, second to last line, y equals 5 plus or minus the square root of x plus 25. Now we've got to determine at this point what we want. Do we want a plus or a minus before we write it in function notation? You can't have both because that would be wouldn't be a function. Because we'd have one result leading, what do you call it? I'm having an absolute brain fade here. What is it? One to many. So in a function, you can have, remember we talked about this at the beginning of, or the end of last year. You can have a one-to-one function, like a linear equation. That's, one x value gives you one y value. And then you can have a many to one, which is where you have a multiple x values leading to one, the same y value. But then when you have one leading to many, it's not a function. okay, just by definition. So what we need to do to determine what we want, whether we want a plus or minus, is look at the information here. X is greater than or equal to 5. Now, if I were to sketch this, and I'm just going to do a quick sketch here, I know that my graph looks something like this. Very not to scale. That minimum point there is at 5. Oh, I've even put it in the wrong quadrant, haven't I? Excuse me, let's just fix that up. Alright, there we go. This minimum point here is at 5, comma, negative 25. And the part of the axis, the part of the function that is defined by this side, okay? We want that side. So the function is for x is greater than or equal to 5. Now, if it's from the midpoint, the minimum point to the right, that means when you do the inverse, that you want a positive. So we want the right hand side, so down here we want 5 plus the square root of x plus 25. And if that doesn't make sense, I think we've talked about it significantly in class, but if it doesn't make sense, another way of doing it is to take a number like, let's say we'll take 6, okay? We put a 6 into this function here. We get 6 minus 1, all squared, minus 25, and what does that give us? Well, 6 minus 5, I'm jumping ahead, is 1. 1 minus 25 is negative 24. And then you put that negative 24 into this here. Negative 24 plus 25 is 1, square root 1. Now, what do we want? 5 plus 1 takes us back to what we had originally, the 6. Yes, not 5 minus 1. So that's another way of doing it. Okay. Alright, I hope that makes sense. Let's move on. Coordinate geometry. So with coordinate geometry here, we've been given 3 points, and we've got to find the gradients and determine of AB, and then BC, and determine whether they are collinear. Now, what the heck does collinear mean? It means they are all on a straight line, like this point, and this point. Okay? Okay, now let's have a look. AB, gradient of AB is equal to, now we take, let's do this, 6 minus 4, that's the change in y, over the change in x, 4 minus 6, which is equal to 10 over, goodness gracious me, Mr. K, 2, 10 over 10, or 1/5. Okay, and m of BC is equal to, let's do the C, 7 minus the 6, so that one and that one, over the 10 minus the 4, which is equal to 1 over 6. Is that right? Hang on. 7 minus 6, 10 over 4 is equal to 1/6. Okay, perfect. Now, therefore, not collinear. You might be thinking, Mr. K, how do you know? Okay, because the gradients are different. Now think about it this way. If the gradient between A and B is 1/5, or 0.2, but then the gradient changes from B to C, it's not as high, like it's smaller, it's 1/6. So the gradient is shallower. You can see that it's not a straight line, because a straight line would have gone on like that. Okay, I hope you get the general idea from my terrible drawing. Okay, now we have to find the perpendicular bisector of AB. The perpendicular bisector of AB. Well, first of all, find the midpoint. Find the midpoint. Okay, of AB. So let's do that. Midpoint AB. I'm going to take my x values, minus 6 plus 4 and I divide them by 2 to find the average, or the midpoint, right? Mid x, and then I'm going to do mid y by going, oh, it's 4 plus 6, isn't it? Over 2. And so you get negative 1, comma 5, I think is the midpoint there. Now, the second step is to, and then, gradient AB. Now we've already found that from the previous question, equals 1/5, I think. And now we work it out. So we use y minus y1 equals m into x minus x1. So what I'm saying here, y1 is the y value of one of the points on the line. Can use, which is here, isn't it? Right? The y value 5, and the x1 is minus 1. And the gradient of the perpendicular bisector. It's a bisector. So therefore, instead of 1/5, we'll have gradient of bisector should be equal to minus 5, the negative reciprocal. So now we can fill this in. Y minus 5 equals negative 5, our gradient, into x minus minus 1. What do we get? Y equals negative 5x. Now this negative 5, it's minus 5 plus 5. There we go. I think y is equal to negative 5x. Okay, I skipped a couple of steps there. Hopefully that makes sense. Slow it down. I'm sure you can figure that out at your level. Okay, now the last one of the day is a differentiation question. We've got a curve. Here it is here. It's got a gradient of 16 when x equals 1. And the second thing we know is that it's got a gradient of 8 when x equals minus 1. And we've got to find the values of a and b. So clearly this looks to be some kind of simultaneous equation. So let's look at this category, this information here. So let's do dy dx, which is our gradient function. So we get a. Now, bx squared, I want you to think about that. B over x squared is like bx to the minus 2. That's another way of writing it. So when we differentiate that, we get minus 2bx to the minus 3. Okay? So that's what it is when we differentiate it. Sometimes students, instead of when you've got a negative power, they add, so they go up, like they might have gone negative 1. But no, remember you're subtracting, the power drops down 1. Okay, so just don't be a Larry there. Okay, now we know it's got a gradient of 16 when x equals 1. Now the gradient is this here, isn't it? That's a gradient function. So we go 16 is equal to a minus 2b times 1 to the power of minus 3, which is 1. So we can just pretty much ignore that. Okay, there we go. There's our first equation. Now let's do another equation for this one here. So we know that when the gradient is 8, so negative 8, so we go negative 8 is equal to, now we use our gradient function, a minus 2b when x is minus 1, and that is times negative 1 to the power of negative 3. Now I'm just going to rewrite this for you. Minus 2b over minus 1 cubed. That's another way of writing it. And we can say therefore that minus 8 is equal to a, and that's minus 2b over minus 1. And another way of writing that, sorry, I'm just doing it really slowly here, is equal to a plus 2b. Okay, so now we can take this equation here and this one here, and I think we could just add them together, couldn't we? So 16 plus minus 8 is 8 equals, and then we get 2a, and the minus 2b, when we add the 2b to it, that cancels out, so we get a is equal to 4. Now let's find out b. Therefore let's pop the value of 4 into this one here. 16 equals 4 minus 2b. 12 equals negative 2b. And therefore b equals negative 6. And there we have it. That is maintenance week 7. Hope it makes sense. If I've made any errors or you don't understand something, feel free to leave a comment or even let me know on ThinkWave, and I'll hopefully be able to talk to you soon. God bless, guys.